Hello friends, welcome to my YouTube channel, Raja Gogasikotar 1719. Today, we are going to talk about the changing the Earth's magnetic poles regarding. In this video, we will explore 1. The invisible force that protects Earth. 2. Magnetic north is not true. North. 3. The chaotic heart of the planet. 4. When the magnetic field begins to flip. 5. Step by step. How a magnetic pole reversal happens. 6. Earth's memory, written in stone. 7. If the magnetic poles flip today. 8. Warning signs from the present day. 9. How science is watching the invisible. 10. Earth is alive. What if the compass you trust suddenly stopped pointing north? What if the invisible shield protecting Earth from deadly space radiation began to weaken? Deep beneath our feet, something extraordinary is happening. The Earth's magnetic poles are moving, and they have flipped before. This is not science fiction. This is a real, repeating event in Earth's long history. Today, we will uncover what Earth's magnetic field really, why the poles move, how pole reversals happen step by step, what happened during past reversals, and the most important question, will it happen again, and what would it mean for us? Stay with us till the end, because what you are about to learn may change how you see our planet forever. 1. The invisible force that protects Earth. Close your eyes for a moment and imagine this. Every second of every day, our planet is being bombarded by deadly radiation from the sun and deep space. Powerful solar winds race toward Earth at millions of kilometers per hour. Yet life continues to exist. Forests grow, oceans breathe, and humanity survives. Why? Because Earth is protected by something you cannot see. An invisible force surrounds our planet like a giant shield. It has no color, no shape, and no sound. But without it, Earth would be a lifeless world. This force is called the Earth's magnetic field. Deep beneath the ground you walk on, far below the deepest oceans and highest mountains, lies Earth's core. At the center is a solid inner core, hotter than the surface of the sun. Surrounding it is a massive ocean of molten iron, constantly moving, constantly flowing. As this liquid metal churns, it generates powerful electric currents. And from these currents is born a planetary-scale magnetic field strong enough to stretch tens of thousands of kilometers into space. This magnetic field is the reason compasses work. It guides migrating birds across continents. It shields our atmosphere from being stripped away by solar storms. Without it, Earth would look more like Mars, dry, exposed, and silent. But here's the astonishing truth. This invisible shield is not permanent. It shifts, it weakens, and over time, it can even flip completely. What controls this force? Why does it change? And what happens when Earth's magnetic poles begin to move? To understand the future of our planet, we must first understand this hidden power that has protected life for billions of years. And this is only the beginning. 2. Magnetic north is not true. North. For centuries, humans trusted a simple belief. North is north. Sailors crossed vast oceans guided by a thin metal needle. Explorers mapped continents, believing the compass always pointed to the top of the world. But the truth is far more unsettling. The north your compass points to is not the true north of our planet. True north is a fixed point, the axis around which Earth spins. It never moves. But magnetic north is different. It is alive. It drifts. and it refuses to stay in one place. Over the past few hundred years, magnetic north has been slowly wandering across the Arctic. At first, it moved gently, just a few kilometers each year. But in recent decades, something changed. The pole began to accelerate. It started racing away from northern Canada, heading straight toward Siberia, at speeds faster than scientists ever expected. This movement is so dramatic that modern navigation systems must be updated constantly. Airplanes, ships, and even smartphones rely on precise magnetic data, and that data keeps changing. Why does this happen? Because the magnetic pole is not anchored to Earth's surface. It is controlled by forces thousands of kilometers below us, inside a world we cannot see. And here is the most important detail. Magnetic north has never stopped moving in Earth's entire history. Its restless motion is not random. It is a warning sign, a signal that the magnetic field itself is slowly changing. And when the magnetic field changes enough, something extraordinary can occur. To understand what that is, we must journey deeper into the hidden engine that drives Earth's magnetic heart. 3. The chaotic heart of the planet. To understand why Earth's magnetic poles move, we must travel far deeper than any human has ever gone. Not into space, but downward into the planet itself. Beneath the Earth's crust and solid mantle lies a hidden world, a realm of extreme heat and pressure, where rock behaves like liquid and iron flows like an ocean. This is the outer core, a massive layer of molten iron and nickel, more than 2,000 kilometers thick. Here, temperatures soar beyond 5,000 degrees Celsius. Nothing is still. Nothing is calm. The molten metal moves constantly, driven by heat rising from the inner core, Earth's slow rotation, powerful convective currents. As this liquid iron flows, it generates enormous electrical currents, and these currents create Earth's magnetic field. This process is known as the geodynamo, the beating magnetic heart of our planet. But here is the crucial point. The geodynamo is not perfectly balanced. The flow of molten iron is chaotic. It shifts direction. It speeds up and slows down. It collides, swirls, and reorganizes itself over time. When these deep currents change, the magnetic field they create changes too. The poles drift. The field weakens in some places and strengthens in others. And sometimes, the magnetic structure becomes unstable. This instability is not a malfunction. It is natural. Earth's magnetic field has never been fixed. It has always been dynamic, constantly reshaped by the restless motion of the core. And when the chaos inside the planet reaches a critical point, the magnetic poles do not just move. They prepare to do something far more dramatic. To understand that transformation, we must now explore one of the most mysterious events in Earth's history, the moment when the magnetic field begins to collapse and reverse. 4. When the magnetic field begins to flip. Imagine waking up one day and realizing that north is no longer north. The compass needle trembles, navigation becomes uncertain, and the invisible shield that has protected Earth for millions of years begins to behave differently. This moment is known as a magnetic pole reversal. A magnetic pole reversal occurs when Earth's magnetic field weakens, destabilizes, and eventually flips, causing magnetic north and magnetic south to exchange places. But this is not a sudden catastrophe. The reversal does not happen in a single day, year, or even a century. It is a slow, complex transformation that unfolds over thousands of years. As the process begins, the magnetic field loses its strength. The once clear north and south poles start to blur. Their positions become uncertain, wandering across the planet. During this phase, Earth may no longer have just two magnetic poles. Instead, several magnetic north and south points can appear at the same time, scattered, unstable, and constantly shifting. The magnetic field becomes distorted, stretched, and tangled. It no longer resembles the simple bar magnet we imagined. And then, gradually, the chaos settles. A new magnetic structure forms. The field strengthens once again. But now, it is reversed. What was once north is now south. What was once south is now north. The last time this happened was around 780,000 years ago, and before that, many times more. Earth has flipped its magnetic poles hundreds of times throughout its long history. Each reversal left its mark, silently recorded in stone and ocean floors, waiting for scientists to decode its story. But the greatest mystery remains. What triggers the magnetic field to cross this invisible point of no return? To answer that, we must look at the evidence locked inside Earth itself. Evidence that proves these reversals are not theory, but undeniable fact. 5. Step by step. How a magnetic pole reversal happens. A magnetic pole reversal is not a single event. It is a slow transformation, a process that unfolds step by step deep within the planet. Let's break it down. Step 1. The field begins to weaken. Everything starts with a subtle change. The magnetic field that surrounds Earth slowly loses strength. This weakening happens unevenly strong in some regions, fragile in others. Right now, Earth's magnetic field is already weaker than it was a few centuries ago. This is not proof of an imminent reversal, but it is a reminder that the field is always evolving. As the field weakens, its protective power diminishes. Step 2. The poles start to wander. Faster. With the magnetic structure destabilized, the poles no longer move slowly. They begin to drift more rapidly and unpredictably across the planet. Magnetic north no longer follows a smooth path. It jumps, curves, and accelerates. This restless motion signals deeper changes in the molten core below. Step 3. Multiple magnetic poles appear. As the reversal progresses, Earth may temporarily lose its simple two-pole system. Several magnetic north and south points can emerge at once. Some last for centuries. Others disappear quickly. During this phase, the magnetic field becomes complex and disordered, no longer dominated by a single north and south. Step 4. The complete flip. Eventually, the original magnetic orientation collapses. The old magnetic north fades away. A new magnetic north strengthens on the opposite side of the planet. The reversal is complete. North becomes south. South becomes north. Step 5. The field stabilizes again. After the flip, the magnetic field slowly regains its strength. The chaos settles. Temporary poles vanish. A stable magnetic structure returns reversed, but familiar. Earth continues its journey, protected once again by its invisible shield. This entire process can take thousands to tens of thousands of years, and throughout it all, life on Earth continues. But how do we know this really happened? How can scientists be certain that Earth's magnetic field has flipped so many times before? The answer lies hidden in ancient rocks records written by the planet itself. 6. Earth's memory, written in stone. Earth has no diary, no written history of its ancient past. And yet, it remembers everything. The proof of magnetic pole reversals is not hidden in myths or theories, it is locked inside the planet itself. When volcanoes erupt, molten lava pours across the surface. As this lava cools and hardens, tiny mineral crystals inside it align themselves with Earth's magnetic field at that exact moment. Once the rock solidifies, that magnetic direction is frozen in time. It becomes a permanent record. Millions of years later, scientists can read these magnetic signatures like pages in a history book. On the ocean floor, this record is especially clear. As magma rises from deep cracks in the seafloor, it cools and spreads outward. Each new layer captures the direction of Earth's magnetic field at the time it formed. What scientists discovered was astonishing. Instead of a single, consistent magnetic direction, the ocean floor revealed alternating magnetic stripe, bands showing normal polarity, then reversed polarity, again and again. These patterns could only mean one thing. Earth's magnetic field has flipped many times. The same evidence appears in ancient lava flows on land. Some rocks point north, others point south. Each layer tells the same story, a planet whose magnetic identity has repeatedly changed. By dating these rocks, scientists have mapped hundreds of magnetic reversals stretching back over hundreds of millions of years. And through all of them, one fact remains undeniable. Life survived every reversal. No global extinctions, no collapse of the biosphere. Earth endured, and so did the life upon it. But this discovery raises a deeper, more unsettling question. If pole reversals are natural and recurring, what happens to a technologically dependent civilization like ours when the next one begins? To answer that, we must look forward and imagine Earth during its next magnetic transformation. 7. If the magnetic poles flip today. If Earth's magnetic poles began to flip today, the change would not arrive with explosions or earthquakes. There would be no single moment of disaster. Instead, the danger would grow quietly. As the magnetic field weakens, Earth's protective shield would become thinner. More charged particles from the sun would reach the upper atmosphere. Radiation levels in space and at high altitudes would rise. For most life on the surface, the impact would be limited. The atmosphere would still protect us. Oceans, forests, and animals would continue to exist, but modern civilization would feel the strain. Satellites orbiting Earth would face increased radiation damage. Navigation systems could become unreliable. GPS errors would grow more frequent. Power grids would be more vulnerable to solar storms. A strong burst from the sun could overload electrical systems, causing widespread blackouts. Air travel would be forced to adapt. Flights near the poles could face higher radiation exposure, putting passengers and crew at risk. Even animal migration patterns might change. Birds, turtles, and marine species that rely on Earth's magnetic field would need time to adjust to a confusing and unstable signal. The most dramatic change, however, would be visible in the sky. Auroras, normally confined to polar regions, could appear across much of the planet, lighting the night sky in places that have never seen them before. A magnetic pole reversal would not end the world, but it would challenge a world built on technology. And that raises an important question. Are we already seeing signs that such a change has begun? To answer that, we must examine what scientists are observing right now, clues that suggest Earth's magnetic field may already be entering a new phase. 8 warning signs from the present day. Right now, at this very moment, Earth's magnetic field is not behaving normally. Scientists around the world are watching it closely because something unusual is happening. Over the past 2 centuries, the strength of Earth's magnetic field has dropped by nearly 10%. This decline is not uniform. Some regions are weakening faster than others. One area in particular has drawn serious attention. It is known as the South Atlantic anomaly. In this vast region stretching between South America and Africa, the magnetic field is significantly weaker than elsewhere on the planet. Satellites passing through this zone often experience electronic glitches, data corruption, temporary shutdowns. This weakening is not new, but it is growing. At the same time, magnetic north is racing across the Arctic faster than ever recorded. Its sudden acceleration suggests deep changes in the molten core below. Yet here is the critical truth. None of these signs guarantee an imminent pole reversal. Earth's magnetic field has weakened and recovered many times before without fully flipping. The planet does not follow a countdown clock. There is no fixed schedule. Scientists believe we could be witnessing the early stages of a reversal, a temporary magnetic fluctuation, or a process that may stabilize on its own. The uncertainty is what makes this moment so important. Earth is sending signals, and humanity is learning how to listen. But even if a full reversal is not close, the changes happening now are teaching us something vital about the fragile balance that protects our world. To understand how we prepare for what comes next, we must explore how science is tracking this invisible force and what humanity can do to adapt. 9. How science is watching the invisible. The Earth's magnetic field cannot be seen. It cannot be touched. Yet scientists track it every single day. Across the planet and far above it, a global scientific effort is underway, one designed to understand a force that shapes life itself. High above Earth, specialized satellites constantly measure the strength and direction of the magnetic field. They detect even the smallest fluctuations, changes so subtle, they reveal movements occurring thousands of kilometers beneath the surface. On the ground, observatories monitor magnetic activity around the clock. Every shift, every anomaly, every sudden disturbance is recorded and analyzed. But observation alone is not enough. Scientists use powerful supercomputers to simulate Earth's core. They recreate the chaotic flow of molten iron, testing how changes deep inside the planet could alter the magnetic field above. These simulations help answer critical questions. How fast can the field weaken? How unstable can it become? What patterns signal a possible reversal? The goal is not to predict an exact date, because Earth does not offer precise warnings. The goal is preparation. Modern technology depends on magnetic stability. By understanding how the field changes, engineers can protect satellites from radiation damage, strengthen power grids against solar storms, improve navigation systems during magnetic disturbances. This research is not driven by fear. It is driven by responsibility. Humanity has reached a point where understanding Earth's deep systems is essential for protecting our future. And as our knowledge grows, so does a powerful realization. We are not helpless observers. We are active participants in learning how to live on a changing planet. But there is one final question that remains a question that connects science, survival, and perspective. What does Earth's shifting magnetic field ultimately tell us about our place in the universe? To answer that, we must step back and look at the bigger picture. 10. Earth is alive. Beneath our feet, far beyond human reach. Earth is constantly in motion. Molten iron flows like an unseen ocean. Magnetic forces rise, weaken, and reorganize. And over immense stretches of time, the planet quietly reshapes itself. The changing magnetic poles are not a sign of danger. They are a reminder that Earth is not a static world. It is alive, dynamic, and evolving. For billions of years, this invisible magnetic shield has protected the atmosphere, guided life, and made our planet a safe harbor in a hostile universe. It has weakened before, it has flipped before, and life has endured every time. What makes this era different is not the planet, it is us. Humanity has built a civilization that reaches into space, relies on satellites, and depends on delicate technological systems. Understanding Earth's magnetic field is no longer just a scientific curiosity. It is a responsibility. The story of magnetic pole reversals teaches us humility. It reminds us that powerful forces operate far beyond our control, yet they are not beyond our understanding. As science continues to decode the signals rising from Earth's core, we gain more than knowledge. We gain perspective. We learn that survival is not about resisting change, but about understanding it. The magnetic poles will continue to wander. One day, far in the future, they will flip again. And when they do, Earth will carry on just as it always has. The real question is not whether the planet will survive. It is whether we will be wise enough to understand the world we live on. So friends, this was today's amazing information. Hope you liked this video and learned something new. If you found the video interesting, don't forget to like, share, and subscribe. See you again in the next video with another new and surprising thing. Until then, stay happy, stay healthy, and stay tuned to learn. Geomagnetic.